We live in a world of casual miracles. Every day, without a second thought, we rely on technology that would have seemed like pure science fiction just a few decades ago. The devices in our pockets are more powerful than the computers that sent astronauts to the moon, and yet we use them to order food, hail rides, and share cat videos. You pull a sleek rectangle from your pocket, tap a screen, and instantly know where you are. With a few swipes, you can see your exact position on a digital map, down to the street corner, the building, or even the floor of a shopping mall. It's so seamless, so effortless, that we rarely stop to consider the invisible web of satellites and signals making it all possible. Your smartphone, powered by GPS, guides you to taco trucks hidden in back alleys, tracks your morning run with astonishing accuracy, and even helps you find your car in a crowded parking lot after a long day. It's your personal navigator, fitness coach, and lost item finder all rolled into one. It just works until it doesn't. Maybe you're deep inside a concrete building or in a remote area with spotty coverage. Suddenly, your phone is lost, searching for a signal, and you're left to wander or wait. For most of us, this is a minor inconvenience, a few minutes of frustration, maybe a missed turn or a delayed meeting. But what if you're not just trying to find coffee, but instead you're flying a 30-ton fighter jet at twice the speed of sound, slicing through the sky at over 1,500 miles per hour? In this world, the stakes are infinitely higher, and the margin for error is razor thin. Here, the stakes are life and death. A single mistake, a momentary loss of position, can mean disaster, not just for the pilot, but for the mission, and sometimes for entire nations. The environment is unforgiving, the speeds are extreme, and the consequences of failure are catastrophic. A GPS glitch in your phone is a minor annoyance. You might get lost for a few minutes or have to ask for directions, but for a fighter pilot, a GPS error isn't just inconvenient, it can be deadly. In a jet, being off by just a few feet can mean the difference between a safe flight and a catastrophic crash. When you're flying at hundreds of miles per hour, even the smallest navigation error can have massive consequences. So, why can't a billion-dollar jet just use the same GPS as your phone? After all, both rely on signals from the same constellation of satellites orbiting high above the Earth. But the reality is far more complex. The answer is a story of vulnerability, extreme physics, and engineering ingenuity. Fighter jets operate in environments where GPS signals can be jammed, spoofed, or simply lost. The physics of high-speed flight, the need for absolute precision, and the ever-present threat of electronic warfare mean that military navigation is a whole different game. Let's dive in. Why are the signals that guide you to your favorite restaurant a potential liability for a fighter jet? How do adversaries try to disrupt or deceive these signals? And what does it take to stay one step ahead in the cat-and-mouse game of electronic warfare? What hostile worlds do these jets fly in? From deserts to mountains, from friendly skies to enemy territory bristling with radar and jammers, fighter pilots must navigate through some of the most challenging environments on Earth, and above it. And when everything else fails, when the satellites go dark, the signals are jammed, and the digital maps disappear, what backup systems keep pilots on course? How do they find their way home when technology falters? Let's get started and uncover the hidden world behind the magic box in your pocket and the supersonic sentinels that guard the skies. To understand why GPS isn't enough for fighter jets, let's first break down how GPS works for something much more familiar: your phone. GPS, or Global Positioning System, is a technology that most of us use every day, often without even thinking about it. Whether you're navigating to a new restaurant, tracking your morning run, or just checking your location on a map, GPS is quietly working in the background, guiding you with remarkable accuracy. Picture this. High above us, about 20,000 kilometers in space, there are around 30 satellites orbiting Earth. Each of these satellites is equipped with an incredibly precise atomic clock, and they're constantly beaming radio signals down to the planet's surface. These signals travel at the speed of light, carrying the exact time they left the satellite and the satellite's position in orbit. Your phone or any GPS receiver is always listening for these signals. When it picks up a signal, it notes the time the signal was sent and the time it was received. By comparing these timestamps, your device can figure out how far away each satellite is, because the signals take a tiny fraction of a second to reach you. But here's the clever part. Your phone needs signals from at least 4 satellites to accurately determine your position. By measuring the distance to each satellite, it uses a process called trilateration to pinpoint your exact location in 3 dimensions: latitude, longitude, and altitude. This is why, even in a crowded city or deep in the countryside, your phone can usually tell you exactly where you are. It's a cosmic dance of timing and geometry, with your position being updated every second as you move. The system is so precise that it can track your movements down to just a few meters, and sometimes even less. What's even more amazing is that this technology is free to use, works almost anywhere on the globe, and is compact enough to fit inside your watch or fitness tracker. It's become an essential part of modern life, woven into everything from transportation to emergency services. But there's a catch. GPS relies on hearing incredibly faint whispers from space. The signals that reach your device are so weak, they're easily drowned out by stronger radio noise or blocked by tall buildings, dense forests, or even bad weather. Now imagine you're in a military fighter jet, flying at high speeds and relying on GPS for navigation and targeting. In military operations, anything you depend on becomes a potential target for your adversaries. If your enemy knows you rely on GPS, they might try to disrupt it. So, what happens when someone decides to shout over those faint whispers from space? With the right equipment, an adversary can jam or spoof GPS signals, making them unreliable or even useless. For fighter jets, this could mean the difference between mission success and failure, or even life and death. That's why for the military, GPS alone just isn't enough. GPS signals are incredibly faint. By the time they reach Earth, they're weaker than cosmic background noise. Your phone's receiver is sensitive, but that's also its weakness. Imagine a quiet library. GPS works until someone blasts a megaphone. That's jamming, blasting radio noise on GPS frequencies, overwhelming the signal. It's easy to do, and can render GPS useless over entire regions. For a fighter pilot, losing GPS isn't an inconvenience, it's mission failure. That's why military GPS uses anti-jam technology, encrypted signals, special antennas, and digital tricks to block out jammers. Your phone doesn't need this, but in a jet, it's essential. If jamming is like shouting at someone to drown out their conversation, spoofing is more like quietly whispering convincing lies into their ear. Instead of simply blocking signals, spoofing deceives the receiver, making it trust information that's completely false. A spoofer works by broadcasting fake GPS signals that are carefully crafted to mimic the real ones sent by satellites orbiting high above the Earth. These counterfeit signals are designed to be even stronger than the genuine ones, so the receiver locks onto them instead. The result? The GPS receiver is tricked into believing it's somewhere entirely different. It's as if someone swapped out the map in your hands for a fake one, and you'd have no idea you were being misled. Imagine checking your phone and suddenly seeing your location in the middle of a lake, or in a city you've never visited. This isn't just a glitch, it's a deliberate attack, and it can happen to anyone using civilian GPS. This might sound like something out of a spy movie, but it's already happened in real life. In the Black Sea, cargo ships have reported their GPS showing them parked at airports miles away from their actual position. The consequences can be serious. Ships could be sent off course or even into dangerous waters. For military operations, the stakes are even higher. If a fighter jet's GPS is spoofed, it could unknowingly cross into enemy territory, miss its intended target, or even become lost in hostile airspace. The margin for error is razor thin, and the risks are enormous. To defend against these threats, military GPS systems use encrypted signals, known as the PY code. This encryption acts like a secret handshake between the satellite and the receiver, ensuring only trusted devices can understand the real signal. Only receivers equipped with the right secret keys can decode these encrypted messages. Without the key, any attempt to mimic or fake the signal will fail, and the receiver will know something's wrong. Spoofers can't break this encryption, no matter how sophisticated their equipment. The fake signals simply don't match the secret code, so they're ignored or flagged as suspicious. This means that military jets and other critical systems can spot and reject fake signals, keeping their navigation accurate even in the face of electronic warfare. Civilian devices like your smartphone don't use this level of security. For everyday navigation, it's usually not necessary, but it does leave them more vulnerable to spoofing attacks. For a fighter jet, though, this kind of protection isn't just a luxury, it's absolutely essential. In the high-stakes world of military aviation, secure and trustworthy navigation can mean the difference between mission success and disaster. Fighter jets like the F-22 travel at over 1,500 mph, Mach 2. At these speeds, a standard GPS receiver can't keep up. It's built for cars, not projectiles. A jet's velocity and maneuvers are so extreme that by the time a regular GPS calculates its position, the jet is already somewhere else. The Doppler effect shifts signal frequencies, confusing ordinary receivers. Fighter jet GPS systems are built for this chaos. They use powerful processors and advanced algorithms to handle rapid changes and massive Doppler shifts, recalculating position thousands of times per second. Where your phone would crash, a jet system thrives. Fighter jets face brutal environments. Temperature swings from 120 degrees Fahrenheit on the runway to minus 70 degrees Fahrenheit at altitude, and constant, violent vibrations. Consumer electronics can't handle this. Your phone might shut down or break. Jet avionics are built to military specs, ruggedized, shock-absorbing, and protected against extreme cold, heat, and vibration. Circuit boards are thicker, components are potted in epoxy, and everything is designed to survive relentless abuse. This level of durability is overkill for your phone, but essential for a jet. Your phone's GPS is accurate to about 10-15 feet, good enough for daily life. But in military aviation, a few feet can mean missing an aircraft carrier or a target. Military GPS receivers use more precise encrypted signals and combine data from multiple sensors, like inertial navigation and radar altimeters. This sensor fusion creates a navigation solution far more accurate and reliable than GPS alone. If GPS data drifts, the system cross-checks with other sensors and ignores faulty data. Your phone has no such backup. So what do jets trust? The Inertial Navigation System, or INS. It's a self-contained box using accelerometers and gyroscopes to track every movement from a known starting point, immune to jamming and spoofing. The downside? Drift. Tiny errors add up over time. That's why jets use a hybrid system. GPS corrects the INS's drift when available. If GPS is jammed or spoofed, the INS takes over, keeping the jet on course. It's the ultimate navigational safety net. Fighter jet navigation is rugged, redundant, and built for survival. Your phone's GPS is designed for convenience, not combat. Military-grade tech in your phone sounds cool, but it would be bulky, expensive, and drain your battery in hours. Plus, military GPS encryption is classified. Putting it in every phone would be a security nightmare. The navigation suite in a jet can cost as much as a car. In the end, each system is a brilliant solution for its world. Your phone gets you to the taco truck, a jet system wins wars. Sometimes, good enough is exactly what we need.